All right, I actually really like this topic because it is an applicable thing. Last time we did areas, today we're gonna do volumes. Now, this does involve having a little bit of an imagination. Do you have an imagination? We had a childhood and imagine things. What is going to happen is you're going to have shapes that are kind of popping up out of the paper at you. Did you have one of those pop-up books when you were a kid where you open it and shapes come up out of the paper? Okay, you have to imagine that happening, and then we're gonna find the volume of the three-dimensional object that gets formed. This is how a 3D printer works. Do you know how a 3D printer will print one slice of the item at a time? So we're gonna have slices of all these shapes creating a three-dimensional thing. To aid with your imagination, here's a picture of a couple of them. So do you see how the base is a circle? On your paper, 2D, like two-dimensionally, all you're gonna see is that circle. You're gonna have to imagine these triangles coming up. You see all the slices of triangles? And it would create a thing that looks like that, three-dimensionally. Here's another one. The base, again, is a circle. Do you see how it's rectangles popping up out of the paper? And creates this as a three-dimensional. Isn't that cool? It's cool, neat, guys. It is, and it's how a 3D printer works. So it is cool. Get on board. Neat. Okay. Now with the areas, and unfortunately, Delta Math didn't give you any that were sideways, but do you remember the DY ones? And I said, you're going to kind of just have to look at it and see if it's right side up or if it's sideways. Good news for these ones, they come right out and tell you. If it says perpendicular to the x-axis, it's dx. If it says perpendicular to the y-axis, it's dy. So they will come right out and tell you which type of problem it is, which is nice. Okay, you don't have to guess. You with me there? Okay, so let's go ahead and draw this. And all you're gonna have drawn on your paper is the base. You have to imagine the shapes popping up out of the paper at you, okay? Base of a solid is bounded by this thing, all right? Let's plug in some numbers. I would start with 0. If you plug in 0, what do you get? 1, 0, 1. If you plug in 1, you're gonna get 1 minus a fourth, 0.7 or 3/4. So you get 1 3/4, and then it's going to be a parabola. You're going to get the buy one get one point on the other side. And then if you plug in 2 squared is 4 over 4 1, so 1 minus 1 is 0. So you get 2 0 negative 2 0. So you get a parabola that looks like this, upside down and kind of like widened out. And then it says we also have the x-axis and the y-axis. So if you bold those axes, you can choose between this kind of shape in here and this one here. Choose the one in the first quadrant where everything is positive, because it's just going to make your life easier. It technically doesn't matter because they're symmetric, but pick this one. So that's the base of this three-dimensional thing. They're going to tell you what kind of shape you've got. And they're going to tell you if it's perpendicular to the x or the y-axis, all your slices, okay? Cross sections are what shape? Squares. Do you see that there? Draw a square off to the side. We're going to label that, so just hold on. And it says perpendicular to the... Okay, that means it's a dx problem. It is right side up. It is straightforward. The world makes sense. Can you watch me for a second? All right. You have an infinite number of these slices perpendicular to the x-axis. Do you see that there? There's like an infinite number of them. What we're going to do is take one slice out and set it aside. Imagine a loaf of sliced bread where you took one slice out of the middle and set it aside. Are you imagining this with me here? I know you are. You're staring off at the wall, okay? So what I usually do is take another color and I'll draw in a slice perpendicular to the x-axis. I always get asked, Miss Cole, why did you draw it there instead of here or here or here? It doesn't matter because there's an infinite number of slices. So you have a loaf of bread with all your slices, you're just pulling a slice out. So this part right here that I just pulled out matches up with the base of the shape. What I just pulled out there matches up with the base of the shape. Do you remember how last time we did upper graph minus lower graph? Or right graph minus left graph if it was sideways? Remember the R and the L? No, like a weekend happened, I get it. But Since this one is right side up, you're gonna do the upper graph minus the lower graph. The upper graph is this, right? The lower graph is 0, it's the x-axis. So it's just gonna be this 1 minus, actually, I'm gonna write it as 1/4 x squared. And once you have that labeled, you are ready to set up your integral. So you are gonna use x values for your boundaries because it's a dx problem. So look at your picture. What are gonna be your boundaries from where to where? Like 0 to 2? Inside of there is the area of your shape. So you're going to be given shapes you can find the areas of, like triangles and squares and semicircles and stuff. How do you get the area of a square? Base times height. Okay, so it is 1 minus 1/4 x squared times 1 minus 1/4 x squared, and then at the end, dx. It's base times height. So yes, but we're gonna do this one by hand, and that's why I wrote it twice, is so you could see it written out. But did you guys all hear that question? Yeah. Okay, because you can just write it as whatever it is squared as well. But I wrote it out twice because we're gonna do this by hand, all right? So integral 0 to 2, now you have to multiply all that out. Welcome back to algebra class. 1 times 1 is 1. The outsides would give you minus 1/4 x squared. The insides would give you minus 1/4 x squared. So together that would be minus 2/4, which is 1/2 x squared. And then when you multiply these, negative 1/4 times negative 1/4 is positive 1/16, and then it would be x to the 4th. Good. Our algebra skills are intact. Then you can do the calculus. So antiderivative. You'll be okay, there's just some fractions. Just x, I heard somebody say it, minus one-sixth x to the third, because you'd want it to be 1/3 x cubed, but there's already a 1/2 there. This one, you would want it to be 1/5 x to the 5th, but there's already a 1/16 there. 16 times 5 is 80. And then what?
Upper minus lower.
Upper minus lower, it's fundamental theorem of calculus. Now, what's the kind of nice thing about this is that the lower boundary is 0, so really you can just plug in 2. So it's going to be 2 minus, oh gosh, 2 cubed is 8, so 8/6 is 4/3 plus, now we're not going to end up like reducing this any further, but I hope you know 2 to the 5th. Do we know 2 to the 5th, or could you figure it out counting a 32 80th? I'm gonna let us stop there because I think we got far enough. But yeah, the area of the shape is what goes inside of your integral. And again, what we found is a volume. They don't typically ask for units on this, but just to be thorough, a volume would be something like feet cubed or meters cubed, like cubic meters or something like that. Okay. Question?
32/8. Yeah.
They'll both divide by 16, so yeah, so 2/5. Sorry, I just, at that point, I was like, we did all the really hard work. I wasn't gonna make you do the rest of it. You wanna keep going and get a common denominator?
No.
No, I wasn't gonna, I mean, like, the concept I'm teaching you is this part, okay? So I wasn't gonna make you do that unless it was like pretty easy. All right, so let's go and try the next one. Base of a solid is the region bounded by one arch of y equals sine of x. Can you please just change the x-axis to count by pi over 2 since this one has trig in it? Like make it count by pi over 2. If you know where sine starts, you'll be able to get the rest of the wave. Where does sine begin?
0.
0, right? Yep, 0, 0. And then it's gonna wave. That's gonna go up, go down, come back, blah, blah, blah. It's like this. So again, it says we want one arch of that. there's an infinite number of arches you could pick from, but which one should you use?
Yeah, that's correct.
Yeah, first quadrant, this one right here would be the smart one to pick. And now that I'm remembering this, I think we are gonna end up needing a calculator for this one, but hold on a second, we'll get it set up and then you can all go grab a calculator. All right, so it is gonna tell you what your shape is and if you're perpendicular to the X or Y axis. So what is our shape? All right, what does equilateral mean? All sides are the same. So it would look like this. All the sides are the same and perpendicular to, okay, so all your slices are going this way. And you have to imagine those triangles coming up out of the paper at you, creating this three-dimensional thing. All right, so we're gonna pull out one slice. Again, imagine a sliced loaf of bread. You pull out one slice and set it aside. Except your slices are triangles in this case. Remember, or imagine a loaf of bread, but your slices are triangles. It'd be kind of weird, but interesting. All right, so it's gonna be upper minus lower. Again, why did I draw it here? It just doesn't matter. There's an infinite number of them. And good, so the base of this is sine of X, because it would be sine of X minus 0. And then we're gonna start to set this up. What would our boundaries be? Again, you want X values because it's gonna be dx. 0 to pi, good. Oftentimes on the AP exam, you get a point for getting the boundaries. If it's free response and they say set up but do not evaluate, you get a point for writing that, all right? Now what goes in there is the area. How do you get the area of a triangle? Good. 1/2 base times height, just leave it blank for a second. What's the base? Because that's easy. Sine of X. The height, we're gonna have to fight for a little bit, but you will be okay, all right? I want you to drop down the height. Call that H, and we're gonna try to look at just this side of it. It's a right triangle, so what theorem can we use? It's gonna be Pythagorean theorem, all right? H squared plus, now it would be this distance squared. How much is, oh my God, perfect. 1/2 sine of X squared equals, now it's the hypotenuse, which is this part. Why is that just also sine of X? Equilateral triangle, all the sides are the same. Now that looks a little scary, but I promise it's not gonna be that bad, all right? We just wanna solve for H. We wanna find the height. So H squared plus, what is 1/2 squared? 1/4 sine squared equals sine squared. And you would subtract this over to try and get H by itself. So if you have 1 sine squared minus 1/4 sine squared, it would be 3/4 good sine. I promised you it wasn't going to be too bad. 1 minus 1/4 is 3/4. And then you have to square root. Now I ran out of space, so I'm just going to go and put it in here. Square root of 3 is square root of 3. Square root of 4. Oh my gosh, it came out to square root of 3 over 2. Let me finish this thought. No. Isn't that crazy that it's square root of 3 over 2? Isn't that nuts? It's crazy. Because this is a 30, 60, 90 triangle, and that's where your unit circle comes from. And then what's your square root of sine squared? It's just sine. Okay, so 0.680. We'll do one more and then we'll do our halfway break. So go ahead and flip over. And I tried to do like a problem that has each different kind of shape that you might see on here. So let's read this one. All right, let's go ahead and graph the base of it. Base of a solid is the region bounded by, all right, what is x cubed plus 1 gonna look like? A wiggle that moved Up one. Okay, so you can start at 0, 1. If you plug in 1, you're gonna get 2. If you plug in -1, you're gonna get 0. Now that looks linear, but you just need to know that it wiggles. All right, you've got y equals 0, which is just the x-axis. And then x equals 1, so vertical line at 1. So you get this part that kind of looks like half of a Hershey kiss or something. But again, that's just the base of it. You have to use your imagination and think about shapes popping up out of the paper at you. They're going to tell you what the shape is, and they're going to tell you if it's dx or dy. So go ahead and read through. What kind of shape have we got? All right, cool. Draw a rectangle. So your loaf of bread is rectangles now. And it says it's perpendicular to, well, okay, you have to make a full commitment to the entire thing being backwards. So instead of y equals, this needs to be x equals. It's not hard, but you have to do it. So how would you rearrange that? All right, subtract 1. I'm just going to write it right above there. Y minus 1 equals x cubed. And then cube, good. Okay, so cube root y minus 1 equals x. Again, I have found over the years that if you circle that, it will make you remember to what to put in your integral. I know it's a really simple, basic thing, but those are the things that save us, so just circle that. So whenever you have your slices, there are an infinite number of slices going this way. Do you see how it's this way now? So when I pull out my one slice and set it aside, it is now going to be right graph minus left graph. And again, I don't know why that helps, but the R and the L, it's super basic, but it helps. So just put it. So the base of our rectangle is going to be what minus what? Think about it. What's our right graph? 1 minus the cube root thing that we circled. So that's the base of your shape. The right graph was 1, just the number 1, minus your left graph was that curve, which we rearranged to be that. Then you're ready to set it up. You need y values because it's going to be dy. So look at your y-axis. What are your boundaries going to be? So, and you guys are good at that. You guys see that 0 to 2? And do you see how your slices go this way? Like you're going from here to here with your slices. All right, so 0 to 2. Inside of there, you put the area of the shape. So how do you get an area of a rectangle? Okay, the base is this. If you go back and read the problem, they tell you information about the height. 2 times that. So it would be 2 times that again. And then dy. Now, when you go to type it, 2 things. Listen to me before you reach for your calculator. Number 1, I know it says y, but you're going to type x because just the same with t, we type x or whatever letter, type x. And in this case, I would do the squared thing because it's just shorter. You can put your 2 here and then do 1 minus cube root of whatever squared because there's 2 of them. Do you get what I'm saying? All right, that's just shorter to type is all I'm saying there, all right? Oops, let me throw my calculator around here. You could even put that to where else? Yeah, you could even put that to like outside of the integral. It's in the math menu. If you ever can't find something, just noodle around in the math menu because that's pretty much where everything is. Sorry, I'm talking while I'm typing this and I'm trying to make sure I typed it right. It might have to think for a few seconds, so just be patient.
Yes.
Did you get 6.4? Okay. All right, so we're going to review some geometry in this one because it's going to be a circle. I know geometry was like ages ago for you guys. Oh, whoops. But let's see what you remember about circles. Do you see how it says x squared plus y squared equals 4? there aren't any transformations for the X and the Y. For example, we don't have like X minus 2 or Y plus 7. Do you get what I'm saying? So it didn't move. The center is still the origin. And do you see how it equals 4? That is R squared, radius squared. So what is the radius? 2. Okay, so the center is at 0, 0. Your radius is at 2. So you're gonna go 2 in each direction and draw a circle. So for example, if it was X squared plus Y squared equals 49, what would we have? Radius would be 7. I know it looks like a squashed orange and not a circle. Circles are hard to draw. Mine isn't perfect either. Yeah, not terrible is what we aim for. See, good enough. Pretty good. As long as it doesn't look like a square, you're all right. All right. It's gonna tell you your shape and it's gonna tell you if it's dx or dy. So what is our shape? Isosceles. Okay, let's talk our way through that. What is isosceles? Two sides are the same. Isosceles right triangles. That's a 45, 45, 90. You're following me there? Because isosceles means two sides are the same. All right. Now it says the leg is the base of it. Don't draw this. Let me show you the two options of how this can go. You can either have your right triangle like this, where the leg is the base of it, or it can be like this, where the hypotenuse is the base of it. Do you see the difference? Okay, they're telling us the leg is the base of it. That's actually better. When it's the hypotenuse, it's a good bit harder, okay? But they're saying one of the legs, which means not the hypotenuse, one of the other sides, is the base of it. And does it say perpendicular to X or Y? X. That's good because that means it's a DX problem. It's right side up. Life is good. However, there is a little bit of algebra rearranging we have to do. That means you need this to be Y equals. Okay, so what would we do to this to rearrange it so Y is by itself? All right, minus the X squared. I just usually write it right next to it. Now, when you square root, you have to put a plus and a minus. So watch, come with me on this. The positive square root is this part. Do you see what I'm saying? So this part is the positive square root of 4 minus X squared. And this part down here is the negative square root of 4 minus X squared. As a heads up, this one is going to look really ugly at first, but then like a whole lot of stuff cancels and it ends up okay. So you just got to trust the process, right? So this is the base of your solid. You have to imagine these triangles popping up out of the paper. There's an infinite number of them. These are your slices. I'm going to pull out one slice. Again, it doesn't matter where I draw that. There's an infinite number of them. And so the base of this is going to be upper minus lower. Upper minus lower, exactly the same as the areas we did. So it's going to be square root of 4 minus X squared. That's the upper one. Minus, what's the lower one? Negative square root of 4 minus X squared. And it's going to be plus. And if you have a square root of blah, 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 plus another square root of blah, 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 you now have 2 of them. All right, then you're ready to set up your integral. You want X values because it's going to be a dx problem. So look over here. What are your X numbers? Yeah, you actually can't mess it up because it's a circle. So it's the same always, but -2 to 2. And inside of there, you put the area of the shape. So how do you get the area of a triangle? All right, 1/2 base times height, dx. I like to set things up blank. If you've been with me for several years, you know I always do that because I feel like it's like the setup is important. Then you can just go fill it in. All right, so what's the base? 2 square root of stuff, 2 square root of that stuff. Now, this is why it's nice if the leg is the base instead of the hypotenuse, because that means the height is also that stuff. Now, don't reach for your calculator because we're actually going to be able to do this one by hand. Go ahead and do one more step where we clean this up. first of all, the 1/2 and the 2 are gonna cancel. Now, there's actually another 2. I'm gonna evict that one. I'm gonna just put it out front. You can do that as long as it's a coefficient. You can't do that with a variable, but I put that 2 out front. So that's taken care of. Now what's left? Well, the square roots are gonna, yeah, it's literally just 4 minus x squared dx. So we can do that, like, we can do it. We can do an antiderivative for that. The 2 is gonna just hang out. What's your antiderivative for just 4? Right, 4x minus 1/3 x cubed such that -2 to 2, and we're gonna do upper minus lower. Let's do the upper one. If you plug in 2, well, you have a 2 there. So it'd be 8 minus 8/3. So that's the upper one minus, and then the lower one, you'd have that 2 again out front, and it would be -8 plus 8/3. It's the same thing except backwards. If I feel like if I forced you to sift your way through that, you could do that, but I'm not here to, like, I'm teaching you the calculus concepts. If I made you do that, I feel like you could do it. Okay. All right, let's try one more. Base of a solid is the region bounded by, all right, 1 minus x squared. What's that gonna look like? It will be a parabola, upside down, and good, up 1. So you can start at 0, 1. If you plug in 1, you're gonna get 0. And then the buy one, get 1 point. If you plug in 2, you're gonna get -3. So that'll look like this. All right, and then this one, I know it's to the 4th. It's actually gonna also be a parabola. It's just gonna be kind of like a more narrow parabola because it's to the 4th instead of the 2nd. It moved down 1, so you'll have 0, -1. And then you'll have 1, 0, -1, 0. It's gonna look something like this. So this is the base of your shape, or your like 3-dimensional loaf of bread here. Oh, I think you came in after I showed this. This is what they look like. You have to imagine it, because we're only drawing the base. Oh, so,
But no, we're only drawing the base of it, the 2-dimensional part. You have to imagine these shapes. It's like a 3D printer. You know how a 3D printer does one slice at a time? These are all your slices. That's what it looks like. But I can't make that happen. I can't make shapes pop up out of the paper at you.
Yeah. Those are all your slices. So you have to imagine like a loaf of bread. But what are our shapes this time? Okay, so imagine a loaf of bread, but all your breads are semicircles. Okay. Oh, yeah, that would be kind of cool. I would like the triangular bread though. I think that'd be fun. All right, they're perpendicular to x-axis. So all your slices are going this way. We're gonna pull out one of them. Again, it doesn't matter where you draw that. There's an infinite number of them. Draw yourself a semicircle. The base of it is upper graph minus lower graph. Remember, if it's dy, it's right minus left, but we're gonna do upper minus lower. So which one is the upper one? The first one, the 1 minus x squared. That's the upper one, minus the x to the 4th minus 1. So I'm gonna clean that up a little bit first. You guys were my purists. You like wanted everything in descending order. So if you distribute this negative, it would be negative x to the 4th. And then what would come next? Yeah, minus x squared. And then plus 2. Good. 1 plus 1 is 2. So then you're ready to set this up. You need x values because it's a dx problem. So look at your shape here, -1 to 1. Inside of there, you put the area of your shape. How do you do the area of a semicircle? Good. 1/2 pi r squared dx. Just leave a blank for r. This always goes well with the semicircles right up until this point. Here's what happens. People put this into that parentheses. And the problem with that is not the radius, it is the diameter. You have to do a half of that. And I get 100% why it throws people off, because do you see this 1/2 right here? They feel like they've already done a half. But that half is there because why? This is a half of a circle, okay? We will use a calculator for this one. We will not be doing this one by hand. I love that you guys waited for me to say that though. Like you thought the potential was there for us to work that one out. But no, we're gonna type that one in. But try and type it exactly like it looks.